Algebraic expressions. Algebraic expressions are everything that we've previously done, say in grade 8. To start off with, an algebraic expression is an expression that contains terms. The terms might be numericals, the terms might be in terms of variables, the terms might be ones that involves exponentials as well as unknown variables. Say for instance, x is a term, 7 is also a term, 0 is also a term. So x plus 7 is also a x plus 7 is a combination of few terms. Now x plus 7 could be defined as an expression, more particularly an algebraic expression. If it was just 7, it would have become a numerical expression. Now, is 0 a term? Can anyone answer me in the chat if 0 is a term? Yes, 0 is a term, because 0 is also something of the similar format as 7, right? 0 is a term. Now, if I come to understand the concept of like terms and unlike terms, if I take x and then 2x, x plus 2x becomes 3x, right? X and 2x are like terms. Now does x plus 2x square becomes 3x square? No, it does not. So they are unlike terms. Now the core idea in mathematics or in algebra particularly is that we can add very ruthlessly, very unapologetically, we can add like terms. If you have say y and 100y, you can just add them and it becomes 101y. If you have say x power 2026 plus 2025 x power 2026, both of these are like terms because the degree of the exponent of x is 2026 here. Here also the exponent of x is 2026. So x power 2026 plus 2025 x power 2026 will be 2026 into x power 2026, right? Now, we're trying to understand where the idea of polynomials starts at all. Say when I have something of the format x, I was asked to call it a term, right? And mathematically that's true. X being a term is true. But then x is a single term, right? X is a one term. So it is a monomial. Similarly, you have x plus y. X plus y is a combination of two unlike terms. X plus y is a combination of two unlike terms. So x plus y will be a binomial. Now, very similarly, say x square plus 3x square. X square plus 3x square. Is this a binomial or is this a monomial? Can anyone tell me in the comments? I mean, in the chat box. X square plus 3x square. X square and 3x square are like terms because x square and 3x square when added they'll simply become 4x square, right? And 4x square is a single term. Since 4x square is a single term, this is also a monomial. You understand? Did you understand the key difference between how we decide a monomial and a binomial? Now, after we get till this point, I'll try to understand x plus y plus z, or x plus x square plus x cube. X plus y plus z, is it a monomial? Is it a binomial? Or is it something beyond that? Yes, it is a trinomial. Monomial refers to a single term entity. Binomial refers to an entity that has two terms. Trinomial refers to something of this format which has three terms, three distinct, three unlike terms. Now, x plus x square plus x cube, is it a monomial, or is it a binomial, or is it a trinomial? Yes, x plus x square plus x cube is a trinomial because x, x square and x cube, all of them are unlike terms. X, x square and x cube are all unlike terms, which is why this is a trinomial. So something involves four unlike terms is something involves more than three terms is a polynomial. It's not exactly more than three terms. Any number of terms, something that involves any number of terms is a polynomial. Polynomial is a generic word. Polynomial is not particularly restricting itself to the degree of the expression or the number of terms in the expression. Polynomial is something that in general refers to an algebraic expression of any format. Now, we'll try to understand the key terms that are involved in our attempt to define a polynomial. The key terms that are involved in our attempt to define a polynomial are: first, degree and zeros. The degree of a polynomial. What does the degree of a polynomial signify? I think you haven't taken down anything from here. I'll just let the slide stay as it is. You can note it down for a minute. Alright. Like Vasvaka rightly pointed, a multinomial is something that involves more than three terms. A multinomial is something that involves more than three terms, and polynomial is a generic term that is applicable to any number of terms being present in an algebraic expression. Now, degree and zeros. When I talk about the degree of a polynomial, before we get into the degree, I think we're now clear with what exponents mean, right? So when I just jot down an expression of the format 4x square plus 2x plus 1, 4x square plus 2x plus 1, if I just write down this expression and ask you to find its degree, the essential understanding is that the degree refers to the highest exponent present in the polynomial. The degree refers to the highest exponent present in the polynomial. And the highest exponent present in here belongs to this term, which is 4x square, and the exponent is particularly 2. So 2 is the degree. Now, after we understand what degree is, now let's get into some exercises of understanding degree on an overall perspective. Say one type of polynomials that are being referred to are polynomials in one variable. Say, okay, Advik is asking me to explain this again. So I'll try to get into this in a more simpler way. We have an algebraic expression, right? We'll try to understand the consequentials. 1 can be written as 1 into x to the power 0. Now this expression becomes 4 times x square plus 2 times x plus 1 into x power 0. Now 4, 2 and 1, they're all coefficients. They're all coefficients of the terms in the polynomial. Apart from the coefficients, we have the variable terms as well, right? One of them is x square, and then there is x power 1, x power 0 is not particularly a variable. X square and x, both of them are variables, with the exponent of x square being 2 and the exponent of x being 1. Now, which is the highest number among these? It's definitely 2. So 2 is going to be the degree of this polynomial. 2 is going to be the degree of this polynomial. Now, we'll try to understand different types of different formations of polynomials to get a clear idea of degree. Say I have 4x square into 3x cube. What is the degree of this term? I think no. I think we've got a little misunderstanding of this. When we have terms in addition, them being unlike terms, 4x square and 2x are unlike terms. So that is why they cannot get added. They cannot get added directly as such. But then 4x square and 2x are unlike terms, so we're not adding them directly. But then 4x cube and 4x square and 3x cube, even though they're unlike terms, they're in multiplication. Now, if we get into the laws of exponents, it becomes 4 times 3, 12 into a power m into a raised to the power n becomes a raised to the power m plus n. This is what we've studied so far, right? This becomes 12 into x raised to the power 2 plus 3. So it becomes 12 into x raised to the power 5. We have a key law of exponents, a raised to the power m into a raised to the power n, and that is equal to a raised to the power m plus n. Now 4x square into 3x cube, 4 times 3 is 12, and x square into x cube is x power 2 plus 3, which is x power 5. Now the degree of this term is 5. Did you, is there any doubt with this, or? If you have got any doubt with this, do express it now. Alright, now this is one kind of formation. The other one would be similar to this. Say 5x power 4 plus 3x cube plus 4x square. Now all of them are unlike terms and they are in addition, so they cannot be added. So we will need to find the degree of this. The highest exponent 2, 3 and 4 is 4. So the degree of the expression is 4. The degree of this expression particularly is the highest exponent involved, which is 4. Now, when I talk in terms of yes, all of you are right. The degree of this term would be x raised to the power 1 and y raised to the power 1. So, it is 1 plus 1. The degree is 2. Alright? Which is exactly why we are able to write something of this sort. X plus y whole square would be x square plus 2xy plus y square. We were able to write this only because of this fact. Because x plus y whole square, the degree is 2, x square degree is 2, and y square degree is 2. So is supposed to be the degree of 2xy. Now, I would like to wait for you to note this down. Havisha, the essential part is that when you have degree as a definition, the degree refers to the highest power, right? The degree refers to the highest power. Now, the core fact or the underlying fact is that the highest is a superlative term, right? Highest is a superlative term. So, the thing is that superlative term refers to the high, like the most big value, which is there'll be only one value, right? So a polynomial will not have 2 degrees. We'll go into zeros, don't worry. Yeah, I would like you to note this down. Now, we'll try to understand what zeros are. Okay, we can have a few more seconds to get the definitions right. Now, yeah, I will explain about that part. Yeah, you people don't worry. I'll get to the core definitions. I'll also give you a clarity about whether the polynomials can have negative powers. Now, a polynomial in one variable, particularly, is an algebraic expression containing non-negative integers. or non-negative exponents directly. Non-negative exponents is known as a polynomial. Alright, now the zeros of the polynomial, before we understand zeros of the polynomial, let's take an expression called x minus 7. For what value of, I can read the sentence again. An algebraic expression containing non-negative exponents is known as a polynomial. An algebraic expression that contains non-negative exponents is known as a polynomial. Now, if I take an expression called x minus 7, x minus 7 is not equal to 7x, or it's not even equal to minus 7x. We need to get it right, because remember always that we cannot directly do anything about unlike terms. X and 7 are unlike terms, so we cannot do anything about unlike terms. Now if I need to find the value of x, particular value of x for which this expression becomes 0, if we need to find the particular value of x for which this expression becomes 0, what would that be? We need to write it in this format: x minus 7 equal to 0, and then we'll transpose the 7 to the other side. Minus 7 becomes plus 7, so x will be plus 7, which is 7. Now x is 7 is the value for which x minus 7 becomes 0, right? X is 7 will be the value for which x minus 7 will become 0. Now x is 7 is the 0 of this polynomial. I hope by now you would have a vague understanding of what zeros of a polynomial mean. The zeros of the polynomial are the values of x. The values of x for which the expression becomes 0. Zeros are the values of x for which the expression becomes 0. Now my expression was x minus 7 and it becomes 0 at this particular value called x equal to 7, which is why x equal to 7 was the 0 of this polynomial. Now similarly, if I take expression x square minus 4, if my expression is x square minus 4, I need to find out the values of x for which this will become 0. How would I do that? Now, if we take random values in place of x, say x equal to 0, x equal to 0 will give you the value for x equal to 0, x square minus 4 is 0 minus 4, which is minus 4. Now for x equal to 1, the value is 1 square, 1 minus 4, which is minus 3. Similarly, for x equal to minus 1, for x equal to minus 1 also, minus 1 whole square. Minus 1 whole square is what? Minus 1 into minus 1. Minus 1 into minus 1 is what? 2 minuses will become a plus, right? So minus 1 into minus 1 will be 1 again. 1 minus 4 is again minus 3. Apart from this, x equal to 2. For the value x equal to 2, this becomes 2 raised to the power 2. 2 square minus 4. 2 square is what? 2 times 2, which is 4. So 4 minus 4 becomes 0. And x equal to minus 2. Similarly with minus 2. Minus 2 whole square is what? Minus 2 whole square is minus 2 into minus 2. Now minus 2 and 2 minuses, so it becomes plus. So it will again become 2 into 2, will end up with 4. Now it will be again 4 minus 4, which is 0. 4 minus 4, which is 0. So the values of x for which this expression is becoming 0 is x equal to 2 and x equal to minus 2, right? X equal to 2 and x equal to minus 2. So the zeros of this particular expression are 2 and minus 2. Alright? I would like you to note this down once. అమ్మా ఆ అమ్మాయి ఎవరో మనస్వి అంటే ఎవరో అమ్మాయి ఒక్క మెసేజ్ రఫ్లీ 30 సార్లు పెట్టింది. వస్తానే ఉంది మెసేజ్ నే
అంటే వాళ్ళ నేమ్స్ మెన్షన్ చేయకపోతే వాళ్ళు అట్లా పెడతారు.
ఇష్యూ వీళ్ళ సైడ్ ఆ టెక్నికల్ ఇష్యూస్
Yeah.
వాళ్ళ సైడ్ ఉన్నాయి. ప్రతి ఒక్కరు సార్ యువర్ స్క్రీన్ చాలా మంది సార్ యువర్ స్క్రీన్ ఇస్ నాట్ విజిబుల్ అని. $920 దాకే కదా. I hope we are done. Now we'll try to understand the basic division of algebraic expressions or basic division of polynomials. First we would do addition and subtraction of polynomials now. Always remember, when you can add polynomials, we can add them on the basis of like terms or unlike terms. Say I have x and I have 2x, I can add it. I have x cube and 2x cube, I can add them. I have x power 10 and 2x power 10, I can add them. But then I cannot add x power 9 and 2x power 10. They will stay as it is, as the sum of x power 9 and 2x power 10. Is it alright? I hope you're catching up. If I have two polynomials, generally polynomials are represented with p of x or q of x. Now p of x is x square plus 1 and q of x is x square minus 1, I can add them and say p of x plus q of x is x square plus 1 plus x square minus 1, plus 1 and minus 1 will get cancelled. Now it is x square plus x square, right? So that becomes 2 times x square. We can add it in this format. But then if I have a polynomial p of x equal to 3x power 10 plus 9x power 5, and I have q of x equal to 5x power 9 plus 10x cube. If I add both of these polynomials, they will stay in the same manner. P of x plus q of x will be 3 into x power 10 plus 5 into x power 9 plus 9 into x power 5 plus 10 into x power 3. It is a standard practice that while writing polynomials, we will write the exponents, the terms in terms of their exponents in descending order. We will write the highest exponent first, which in this case it was 3 into x power 10, right? After that, the next power in descending order would be 9. So we will write 5x power 9. After that, we will write 9x power 5, and then we will write 10x cube. Alright. So this is how we add polynomials. Like the polynomials can be added only on the basis of like terms or unlike terms in terms of their degree. Alright. If the degree is same, they can be directly added. If the degree is not same, they cannot be directly added. They'll just be written as the sum of two different distinct terms. Okay. Now, this is about addition. Now, what about subtraction? If I have a polynomial, px is, say 4x cubed minus 3x square, and then q of x is 3x power 3x cubed plus x square. Find p of x minus q of x. Can I have some answers in the chat box? Can I have some answers in the chat box? If px is one of my polynomials and px is equal to 4x cubed minus 3x square, and qx is my second polynomial, which was 3x cubed plus x square, we need to find the difference of px and qx. How do we do that? P of x is 4x cubed minus 3x square. Q of x is 3x cubed plus x square. Now, if I need to subtract them, P of x minus Q of x, it will be 4x cubed minus 3x square. This is P of x, minus Q of x will be 3x cubed plus x square, right? Now, 4x cubed minus 3x square will stay as it is. If this minus goes inside, it will be distributed to both the terms, right? Distributive law. Now since it will be distributed to both the terms, they will become minus 3x cube minus x square. Now try to group the like terms. The like terms are 4x cube minus 3x cube minus 3x square minus x square. 4x cube minus 3x cube. 4x cube. I have 4x cubes and then I throw away 3x cubes. I'll be left with 1x cube, right? So this will be x cube minus 3x square minus x square. Minus 3x square minus x square. As in, I have 3x square and I get a one more x square with negative sign. All of this have negative sign. So 3 plus 1, 4x square with a negative sign. So it will be minus 4x square. I just had 4x cube minus 3x cube. Since they are like terms, they are what? Like terms because the exponent in both the terms is 3. It's x cube and x cube. Now 4x cube minus 3x cube became x cube, and apart from that, minus 3x square minus x square became minus 4x square. Alright? I think with this we have reached a certain level of clarity in terms of how it's supposed to be. You note it down? Alright, so we're back. I hope you've taken the notes down for this. We'll move on to the next topic. Right now we've so far covered addition and subtraction. We'll now have to cover the multiplication and division of polynomials. To start off, we'll start with the multiplication of polynomials. We'll start. So, regarding the multiplication of polynomials, there are certain rules and we'll try to understand that with a simple example. We'll try to consider two polynomials. P of x is x plus 1, q of x is x plus 2. We'll now try to understand the multiplication of polynomials by multiplying both of these polynomials. X plus 1 into x plus 2. Now, if we go by the distributive property, this becomes x plus 1 will be treated as one entity. So it will become x plus 1 times x plus 1 times 2. Right? This is the distributive property of addition, multiplication. Now, x plus 1 times x into x plus x into 1. X into x times x is x square plus x times 1 is x, right? After that, 2 times x is 2x and 2 times 1 is 2. Now our job is to understand if there are any like terms in here. X square is by itself, there is no like term apart from x square. X and 2x, this is x raised to the power 1 and this is 2x raised to the power 1. X plus 2x will be 3x and then 2. So this is how we multiply polynomials. Alright, okay, we'll do this again. We'll let the example stay as it is. We'll try to solve it in another method. Now, when we have x plus 1 into x plus 2, the first idea is that imagine this is some kind of normal multiplication in terms of numbers. Say that is 3 plus 2 into 5 plus 6. How can this be done? I can multiply 3 and 5, so that will be 3 into 5 plus. I can multiply 3 and 6, it will be 3 into 6. 2 and 5, 2 and 6. Right? So this will be 3 times 5 is 15, 3 times 6 is 18, 2 times 5 is 10, and 2 times 6 is 12. Right? So 15 plus 10, 25, 18 plus 12 will be 30. So 25 plus 30 is 55. Now verify this. 3 plus 2 is 5, 5 plus 6 is 11. So 5 times 11 is 55, right? Are they both the same? They are, right? Now, we'll apply the same thing here. We'll start off with writing x into x plus x into 2, 1 into x, 1 into 2. Right? Now if you observe x into x is what? X square, right? Any number multiplied by itself is a square. So x into x will be x square. 2 into x will be 2x. 1 into x will be x. 1 into 2 will be 2. Right? Now look at the like terms. Like terms are the terms that have the same degree, right? So 2x power 1 and 1x power 1. So this will be x square plus 2 plus 1, 3x plus 2. So this is how we multiply polynomials. Now I hope you would have understood by now how we multiply the polynomials. Alright, take a minute to process, take a minute to note this down. We'll start discussing this again. If it's getting late for you, you can actually snap a screenshot of the screen. I think that would help you make a proper notes later. Alright, we'll continue with the multiplication. We've done the multiplication so far for simple polynomials, right? This was in regard to the simple polynomials. Now we'll try to do this for a little bit higher polynomials. I'll take, say, a polynomial called x square plus 2x. And the other polynomial, I'll take it as x cube plus 4x square plus 3x plus 1. Now we need to understand how we are going to multiply this. Alright? We need to understand how we are going to multiply these polynomials. Now I'll just write it as x square plus 2x into x cube plus 4x square plus 3x plus 1. Firstly, x square into x cube plus x square into 4x square, x square into 3x plus x square into 1. Right? X cube multiplied by each of the following terms. X cube x square multiplied by each of the following terms is this expression, plus 2x multiplied by each of the following terms, 2x into x cube, 2x into 4x square, 2x into 3x, and 2x into 1. Now, x square into x cube, as we've already discussed, a power m into a power n will be a power m plus n, right? So, x square into x cube will be x power 2 plus 3, which is 5, plus x square into 4x square. I will write down the 4. X square into x square will be x power 2 plus 2, which is x power 4, right? Similarly, x square into 3x, I will write down the 3. 3 times x square into x is x cube, right? X square into 1 will be x square as it is, plus 2x into x cube, we'll write the 2 here, x into x cube, x power 1 into x power 3 will be x power 1 plus 3, right? Since x power 1 into x power 3 will be x power 1 plus 3, it will be x power 4. 2x into 4x square, 2 times 4 is what? 8. So we'll write the 8 here, x into x square, x power 1 into x power 2, which is x power 3. 2x into 3x, 2 into 3 is 6, x into x will be x power 1 into x power 1, which is x square. 2x into 1 is 2x. Now start by writing all of these in terms of the like terms. There is only one x power 5 throughout this, right? So we'll write x power 5 here. We've written x power 5. Next, x power 4. There is a 4x power 4 here and there is a 2x power 4 here. 4 plus 2 is 6x power 4. There is a 3x cube here. There is an 8x cube here. So 3 plus 8, 11x cube. There is an x square. There is a 6x square. 1x square and 6x square. So 1 plus 6 is 7x square. And finally there is only one x to the power 1 term. So it will be 2x as it is. So if we multiply both of these polynomials, our resulting expression or the resulting polynomial expression would be this. Alright. Yes, Jashmita, that's exactly what we call as a distributive property, or exactly that's what we've done here. So yes, you can do that. You can multiply x square with the expression, second expression, and then you can multiply 2x with the second expression and add both of the resulting expressions. You'll get the same sum as what we've gotten here. I hope by now you would have understood the essence of multiplication. Alright, now we will get to the next part, which is division. So while doing division, we need to have two different types of clarities. The first clarity would be in terms of division by monomial. If we have a clarity in this part, only then we can understand division by a polynomial. Now, coming to division by monomial, coming to this particular part called division by monomial, we'll first enhance our knowledge or brush up our knowledge so far in terms of first essence is division of a monomial by monomial. If I have a monomial called 4x cubed divided by 2x square, what will that be? 4x cubed divided by 2x square. 4 divided by 2 results in 2, and then x cubed divided by x square. X raised to the power 3 divided by x square will be x power 3 minus 2, and the coefficient will be 4 divided by 2, which is 2. I hope this part will be clear. Alright. This is pretty much what we have learned in the exponents itself. Now, if we try to understand the division of a expression by a polynomial, by a monomial, division of a different expression, a polynomial expression by a monomial. Say I have 8x cubed plus 6x square divided by 2x. What will it be? It will more or less be 8 if we separate the sum, since that is a common denominator. I'll write it as 8x cubed by 2x plus 6x square by 2x. Now 8x cubed by 2x, 8 divided by 2 shall be 4, x power 3 by x power 1 will be x, a power m by a power n will be a power m minus n, right? So that will be 4 times x raised to the power 3 minus 1 plus 6 divided by 2 will be 3, and it will be x power 2 minus 1. So it will be 4x square plus 3x. 4x square plus 3x. This is the resultant quotient upon division of a polynomial expression by a monomial. Quickly note this down. $10.20 దాకా కదా. Now we'll try to understand the division of a polynomial by a polynomial. I'll give you a recap of how to divide by a simple monomial. Be careful again. Carefully listen this time. First of all, monomial by monomial is simple. We will just use the rules of the laws of exponents, and based on that, we'll come to a conclusion. It's a single term. Now, when it is in terms of polynomial by monomial, we'll split up the polynomial. We'll split up the polynomial accordingly, and then we will come to the conclusion. We'll split, say, this is equivalent to a plus b by c, right? It's a fraction. Now I can write it as a by c plus b by c, right? Similarly, this is what I've done. I've just separated this. I've separated both of the terms. After that, I've taken the quotient of respective terms. Quotient comes by considering the coefficient and then simplifying the exponent further. So 4x cubed by x. So it became 4x square. 6x square by 2x just became 3x. This is division by a monomial. Quickly take a screenshot. I'll be out of frame. We'll proceed once you take a screenshot. Alright, take down this particular question. Where have we come? You can take down this particular question. Divide the polynomial x square plus 3x plus 2 by x plus 1. I want you to try this for a minute or two. Based on that, yes, Vasavika, Yashvi, we can take the common factor, but then I did not explicitly teach common factor here. So currently I'm not showing you that process. Otherwise, yes, you are right. We can do that, we can solve that using that method also. As of now, I want every one of you to give this question a try. Take 2 minutes. Try to understand the essential fundamentals of what happens when division is happening here. ఆయనది ఎలా అవుతుందంట రాధాకృష్ణ సార్ది అంటే వైబ్రెంట్ అని పెట్టాడు. ఈ మాడ్యులస్ అనేది ఫిడ్జీ వాళ్ళది కదా, ఎక్స్ ఫిడ్జీ ఫ్యాకల్టీ. మాడ్యులస్ అనే ఒకటి ఉంది కదా. నెహ్రూ బాబు అని ఎవరో ఒక ఆయన. ఓ నాయన పర్లా, మరీగా అర్థాలు లేరు, ఆన్సర్ పెడుతున్నారు. గూగుల్ చేసి పెడుతున్నారా? వంశీ సార్ ఏం చెప్పాడంటే, సిలబస్ అవ్వకపోయినా పర్లేదు, నువ్వు ఫస్ట్ స్లోగా ఉన్నట్టు అనిపించాలి వాళ్ళకి, వాళ్ళకి ప్రతిదీ అర్థమైపోతుంది అనిపించాలి. ఎవరు రికార్డ్ చేస్తుంటాడు కదా. ఆహా, ఫోన్లో నేను వచ్చిన వెంటనే మ్యూట్ చేసే కూర్చున్నాను కదా.
లేదు ఇక్కడ వస్తుంది.
ఏమైందంట అది ఎందుకు? ఇందాక నేను మ్యూట్ చేసానా మళ్ళీ అన్మ్యూట్ అయింది. మీ దగ్గర ఉన్నది హోస్ట్ అకౌంటా? ఇప్పుడు మ్యూటే ఉంది. Okay, the answer is x plus 2. Yes, many of you got it right. I'll still let others have a minute. We'll start it, we'll explain this at 10:05. Karthik, this is from polynomials itself. All of this pertains to the chapter polynomials. It's just that I want to brush up the basics for you, which is why today I'm trying to get the basics right. Is it right? Is it all right, Karthik? Cool. So we will try to understand how this division works. Division, generally we do the long division method, right? You take this here, the dividend, the divisor here, and the quotient here. You'll be left with the remainder here. This is exactly what we'll be doing now. Now, x square plus 3x plus 2 should be divided by x plus 1, which means this is the dividend, so the dividend will be written here. This is the divisor, so the divisor will be written here. Before we get into the actual reasoning, try to understand this part. First, consider the first terms of both the dividend and the divisor. X square by x will return an x, right? X square by x will be x power 2 minus 1, which is x power 1. So that will be x. Essentially that means we need to take an x here. Now, x into x plus 1 is what? X into x plus 1 is x square plus x, right? X into x plus 1 is x square plus x. So x square plus x shall be written here. We'll try to subtract this. X square minus x square will result in 0 plus 3x minus x. 3x minus x is 2x plus 2. Alright. Now again, 0 plus anything is again the same, so I will not write this here. Now 2x is here and there is an x. So 2x by x will be, if x gets cancelled, 2x by x will be 2, which is why 2 times x plus 1. So we will write a 2 here, we'll add a 2, x plus 2, and 2 times x plus 1 is 2x plus 2. So 2 times x plus 1 is 2x plus 2. Now we'll subtract 2x plus 2 from 2x plus 2. 2x minus 2x is 0, 2 minus 2 is 0, so we'll be left with a remainder of 0. So when we divide this expression by x plus 1, the quotient will be x plus 2. Alright, I hope all of you have gotten the clarity required. I'll still look at the chat box, try to understand what happened there. Students who want me to explain this again, sure. Varshit, I'll explain this again. Ritvik, yes, I'll explain this again. Alright, we'll start off with what should be multiplied with x to give x square. We should multiply x, right? I think that part is clear. Now, that is why we write an x here. Once we write an x here, x is a part of the quotient now. So x times x plus 1 is x square plus x. So I'll write x square plus x here, right? This is the first step. I'll try to understand what when multiplied with x here gives x square. It is x. So x will be written here and x multiplied with x plus 1 will be x square plus x, which will be written here. Now, x multiplied by x plus 1 will be x square plus x, which is written here. After that is written here, I'll now try to subtract this from x square plus 3x plus 2. X square plus x, when subtracted from x square plus 3x plus 2, I'll be left with 2x plus 2. Now again, we need to see what when multiplied with x plus 1, x gives 2x. So 2 into x gives 2x. So I'll write a plus 2 here, and 2 times x plus 1 is 2x plus 2. So the remainder became 0. So finally my quotient was x plus 2. I hope this is clear. You can note it down. Ore naina.
అదే అక్కడే వాళ్ళు టచ్ అయిపోతాం.
Okay.
మధ్యలో ఇంకా ఉంటుంది.
Take a minute to note this down. Tomorrow we'll be doing the factor and remainder theorem. The day after we'll be doing algebraic identities. After that we'll proceed to the next chapter. Alright? Yes, you can solve it in any other method that you're confident with, but this is the basis of all the other methods. This is the basic idea which gives you how division is to be performed on polynomials, and based on that we'll proceed to other. We ourselves can invent a new method if we want. So that is how we function with math, right? It's always the core idea when developed with some particulars will give the final output in different formats. ఇడెవడో నా పేరు అడుగుతున్నాడు. మరి మీ పేరే 2 సార్లు పెట్టి జిడ్డులా తగులుకుంటున్నారు ఈ పిల్లలు. వదులుకుంటే చంపి. Yes, the chapter is very much in the syllabus. All right. Yes, you can split the middle term and then multiply. Yes, way, but then that is what I still haven't taught, which is why I refrained myself from giving you that method. ఇడెవడో నాకు సోపేస్తున్నాడు. Awesome class sir అంట. We'll proceed with the next example. With that, we'll close the division of polynomials today. Yes, I want you to perform the division of, I want you to perform the following division. Divide x cube plus 6x square plus 11x plus 6 by x square plus 3x plus 2. I want you to perform this. Ved, Vasavika and others who are answering me in the chat about the splitting the middle term. If you are confident enough to split the middle terms in a cubic expression as well, fine, follow that method. Otherwise, the long division method is applicable to any other term. Okay, long division method is applicable to such situations where there are 100 terms in the numerator and there are 50 terms in the denominator also. Long division method gives you the final answer, which is why I would like you to prefer this method. Okay, you can try it for 2 minutes. We'll discuss this after that. చైనాలో జనార్దన్ అని ఒక ఆయన ఉండేవాడు, ఫిజిక్స్ ఐడియా ఉందా? ఇప్పుడు ఫిడ్జీ మాదాపూర్ స్వప్న అని ఒక ఆవిడ ఉంటుంది ప్రిన్సిపల్. ఆమె ఫ్రాంచైజ్ ఆమె కొనుక్కొని ఫిడ్జీ మాదాపూర్ క్యాంపస్ రీఓపెన్ చేస్తున్నారు. చాలా డబ్బులు ఎక్కువ ఇచ్చి తీసుకున్నారు ఆయన్ని. ఎందుకంటే ఆయన మొన్నటిదాకా కేకే సార్, వంశీ సార్ పార్ట్ టైం చెప్తుండే కదా కేకే సార్ దగ్గర, అట్లానే జనార్దన్ సార్ కూడా చెప్తున్నాడు. ఇంకా ఆయన్ని తెచ్చుకుంటున్నందుకు ఆయన అక్కడ చదివే మంచి పిల్లల్ని తెస్తున్నాడు వీళ్ళకి. మరీ గలీజ్ బిజినెస్ అయిపోతుంది ఇది. అప్పుడు తెలుసా, వెలాసిటీకి రమ్మన్నప్పుడు అంట అశ్వత్థరావు సార్ని ఫోన్లు చేయమన్నారంట పిల్లలకి. అశ్వత్థరావు సార్ చేస్తాడట. నాకు జయదేవ్ సార్ చెప్పినాడు. జయదేవ్ సార్ని కూడా చేయమని విన్నారంట. జయదేవ్ సార్ చేయలేదంట. అంటే వాళ్ళు చెప్పుకున్న పిల్లలకి అన్ని రోజులు మంచి సెక్షన్స్ చెప్పేవాళ్ళు కదా వాళ్ళు, ఆ పిల్లలు వస్తే ఇదవుద్దని. అశ్వత్థరావు సార్ కోసమా? అప్పట్లో ఆయన క్రేజ్ ఉండేది. ఏదో ఒక ఇయర్ అంట ఆయన ఒక రష్యన్ బుక్, ఫారిన్ ఒలింపియాడ్ బుక్ తీసుకొని దాంట్లోంచి ఒక క్వశ్చన్ నోట్స్లో చెప్పాడు. ఆ ఇయర్ ఐఐటిలో అదొక ప్యాసేజ్ టైప్ క్వశ్చన్ లా వచ్చింది. అంటే 2 questions into 3 marks, 6 marks. అక్కడ అందరూ చూసి కళ్ళు మూసుకొని పెట్టి ఎవడరా బాబు ఎందుకు స్పామ్ చేస్తున్నారు? Yes, the answer is x plus 3. All right, the answer is x plus 3. It's good that most of you are giving me the answer in chat box. It would be better like if you give the answer once and leave it there, because you have multiple messages. I'm not able to concentrate on any message. That's the funny part. Fine. We can discuss this. All right. Now, going by our earlier method, we'll write the dividend here. X cube plus 6x square plus 11x plus 6. And my divisor should be written here. X square plus 3x plus 2. Now think in this format. What can be multiplied with x square? What can be multiplied with x square to give x cube? It is x cube by x square, right? Which is finally x. So I'll first try to take an x here. If I take an x there, x into x square will be x cube, right? X into x square will be x cube. x into 3x will be 3x square plus x into 2 will be 2x, right? Now we need to subtract this. X cube minus x cube will be 0. 6x square minus 3x square will be 3x square. 11x minus 2x will be 9x. If there's nothing here, it's assumed that there's 0. So 6 minus 0 is again 0, 6. Now understand it this way. What can be multiplied with x square to give the highest term here is 3x square. So to give 3x square. So that will be 3x square by x square, right? So that will be 3. So I'll write a plus 3 here. 3 times x square will be 3x square. 3 times 3x will be 9x. 3 times 2 will be 6. So 3x square plus 9x plus 6 minus 3x square plus 9x plus 6. All of the terms are same. So everything is going to get cancelled to leave us with a remainder 0. So 0 is the remainder here. This part is the dividend. This expression is the dividend. This is my divisor. And x plus 3 is my quotient, which is the answer. Alright. With this, I would like to close the class today. I would want you to get a clarity on the division algorithm, and I would like you all of you to get a clarity on the division algorithm of polynomials, because tomorrow we'll be doing factor theorem and remainder theorem, and then the day after we'll be doing algebraic identities. All of these will be majorly concentrated with this part of division algorithm. Alright, so we will end it here. We have so far covered in today's class. We've tried to understand the definition of polynomials. We've tried to define what a degree is. We've tried to define what zeros of a polynomial could be and how they're going to affect the polynomial as such. After that, we've moved on to understand the core essentialities of operations on polynomials. Say the addition, say subtraction, say multiplication. In multiplication, we try to understand simple and simple ones, and then complex polynomials. Here, in division also, we've tried to understand division of a monomial by a monomial. Later, we've moved on to division of a polynomial by a monomial, and then we've performed division of a polynomial by a polynomial. We've done that for 2 examples. Once simple polynomial, once a divisor being a compound polynomial. So with this, we will end the class today.
Dear students, how are you all? Hope everyone is fine. Good morning, everyone. Is my voice clear to you people? Very good morning. Is my video clear to you people? Fine. Okay. Hello. Yes. Okay, fine. So hope you enjoyed yesterday. Yesterday was holiday. So hope you enjoyed. Right? So everyone yesterday in the morning, I think they took a very good break, either by just going out or by having a good sleep in the morning. I think so. Right? Your yes shows the excitation that you enjoyed last day. Yesterday, I mean. Okay. Okay, then today we are going to deal with a concept, or not concept, we are going to deal with the questions. Do we have holidays homework? Yeah, you will come to know by the end of this session what will be the holidays homework and all. If it is there, you will come to know, no doubt. 100% you are going to come to know across that part. Yesterday, day before yesterday, you were asking me continuously whether tomorrow, yesterday is a holiday or not. And as I said you that you will come to know all those things by the end of the session, and you got the notice, I hope so. Followed by the same thing, here also you will also come to know all those things their regular basis pay. And now let us start with our today's part, which is the worksheet number 3. And before going to this worksheet, I want you to ask certain questions from our very last class. Whatever the questions are there, I am going to ask you, you have to answer me. Okay, you have to answer me. Ready? Everybody ready? Yes or no? Fine. So my first question to you is, my first question, and I want very sweet and short answer from your side, because online if you type it will take more time. So my small and easy and first question is, define conductor. Define conductor. Let's see. Students started giving the answers. Define conductor. Very interesting, but I cannot read all your messages. Very fast answers I am getting. Okay, okay. I don't want example, I want exact definition, or your answers are very fast. Very good, very good. This means that you have remembered our last sessions. Very good, yeah. Fine. I believe that few of them are copying from ChatGPT and sending the answer. I believe, but I'm sure that they are not doing. Very good, very good. Fine, everyone is giving the answer. That sounds very good to me, and that means, yeah, I can see your messages, but in the screen I can see instantly only 3 messages at a time. But in the same second, if multiple students are messaging, then I hope you understood. Multiple students are messaging, then that message automatically goes up. I cannot say. Right? Okay, fine. Coming to the point here. So conductor means nothing but which allows the current to pass through them. Okay, very good. Can you give me example of conductor? What are the examples of conductor? What are the examples of conductor? Someone is saying copper. Examples of conductor. I'm able to see your answers. 1 or 2 examples, more than enough. More than enough. Okay, okay. Nice here. Just a minute. Metal, copper, yes. Okay, tap water also, yes. Metals, iron, human body, copper. Great. Yes. Okay. Coming back to the point. So this all are basically, yes, salt water also is a conductor, correct? Okay. Gold, yes. Now coming to the point here. So today we are going to start with the worksheet. Tungsten comes under the, yes, you can consider it as a conductor also, which conducts electricity basically, and tungsten plays an important role in case of a bulb. Lime juice, that if we can say it as if it consists of salt water, then we can say yes. Great. Copper, tap water, metal and salt water. Exactly correct. Yes. Okay, fine. Shall we proceed for today's part? Someone is giving Einsteinium. Okay, tungsten has high melting point. Yes, of course, tungsten has high melting point. Correct. Okay, so my next question, before that only you answered. Very good. Someone is asking, someone has given the definition for the insulator, but I was not going to ask actually. Okay, fine. Let's go for the next case. Just concentrate very carefully. I think majority of the students can answer this. Okay. So before going to that, everyone, yes, of course, I'm going to start the class here. These are very easy questions. You can answer it easily, but I also want to know what you have studied from the last session. Did you remember that part? Did you remember? And I'm able to see, yes, everyone is able to answer this one. Okay, let's start for today's part. Now, here is the first question of the day. Majority students can answer this. Let's start with this case. Cell is a device which converts what? Cell is a device which converts, hold on please. Right. Cell is a device which converts chemical energy into electrical energy into light energy, no. Electrical energy into magnetic energy, no. Yes, of course, first option is a correct answer. It's a direct option. Everyone is able to answer. That's great. Everyone is able to answer. The cell is a device which converts chemical energy into electrical energy. So very easy question, first one, very simple question. I believe almost all the students has given the answer. All the students. Just I turned here and I saw there are 753 messages for me right now. 750 messages, 751 now. Okay, fine. Just I'll do it down. Fine. Okay. Coming to the point. Nice. Everyone is sending A. That's great. Fine. So let us go for the next question. Everyone got the answer. Okay. Let us go for the question number 2. So in question number 2, what he has given? 4 cells fixed on board are shown below. Connect the terminals with wires to make a battery of 4 cells. Before going to this, I want to answer you. I want to ask you. All the students started giving the answer. Very good. That's great. Very nice here. Interesting class. Let's come back to the point. So here there is one part that you should be familiar in this case. To make a battery from a cell, one positive terminal should be connected to the negative terminal. And you can see what are the positive. These parts are this box type. You are able to see these are actually considered as positive terminal. Those who do not know the answer, they can concentrate very carefully. So you can say this part is treated as positive, this part is treated as negative. Meanwhile, the bottom part is treated as positive, and here B part is actually treated as negative. Then again C part is treated as positive, and R is treated as negative of a cell, and then again positive, and then again negative. I think everyone got till here. Positive, negative. The box, whatever you are able to see, that is basically treated as positive, and the bottom one is taken as negative. So now to make a battery of a 4 cells, you have to connect the positive terminal of one battery to the negative terminal of the other battery. With that case, I will connect A to B, and then I will connect Q to R, and then I will connect C to S, and now this will behave like a battery. Majority students give the answer. That's very good. So therefore I can say A connected to B, and then Q connected to R, and C connected to S. Okay, 2 times it's a printing mistake, and you can see the answer C is the correct answer for this. My God, 1600 plus messages. Everyone gave the answer. Sounds very good here. Some students give us D. That's wrong. C is a correct answer for this. Okay, now fine. Okay, right. So these are very easy questions. Very easy questions. If I gave you one question on this, can you solve and say me yes or no? Can you solve and say me? I'm not going to give the options here. I'm not going to give the options. Okay, right. Now coming to the next case, someone is asking that the 4th option continuously, he is just messaging. Let me clear his doubt here. See boy, whoever is it, plus C is connected to the negative side. So C to S. The C to S, I think he is clear with this first 2 points. This C positive is connected to the negative side. So therefore C to S, it's done. I hope now that particular student got the message. What exactly is it? Very good. So now let us go for the next question. But before going to the next question, I would like to ask you one simple question in this case. I'm just giving you one question. Okay? Let us take an example here. I'm taking the same battery here. But these, cells I'm taking here. But these cells are connected. Are there in this way? Okay? Now, I have how many cells you are able to see? 1, 2, 3, 4, 5. 5 cells are there. I want to make it like a kind of battery. So now I'm taking, this is positive, this is negative, this is positive, this is negative, and this is negative, this is positive, this is positive, this is negative, and this is positive, this is negative. And now I am naming them. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. To make a battery, what are the connections that has to be given? Your time starts now. I'm not going to give the option. You have to say me 1 connected to 4, 3 connected to 2, whatever it may be. You have to give the answer accordingly. Let's see how many students are going to give the answer. Very good. Students started giving the answer. Very good, very good, very good. Fine. Very good, very good. Okay. Yes, there are 5 cells. 1, 4, 5, 8, 1, 0, someone is saying. 1, 4, 6, 8, 9, someone is saying. Okay. Fine. Let us come back to the answer. Everyone is giving the answer. That's quite interesting. You're trying. Very good. You're trying. That's very good. Okay, let us come back to the point. So everyone knows what is connected here. 1 is connected to 4. Yes or no? 1 is connected to 4. And then after that, what should be connected? After 1, 4, what should be connected? After 1, 4, who should be connected to whom? 1, 4, after that, who should be connected to whom? 1, 4, 1 positive. See here, 1 positive, 2 negative, then positive, 2 negative. Few answers I am able to see some students are saying wrong. That's why I am saying here. So you can see from positive to negative, 3, 5. How many students got this? Yes or no? 3, 5. Okay, no, no, no. Okay, this is a very good thing one student said. Okay, so someone is saying that, okay sir, actually got little quick. Okay, okay, no problem, no problem, but this problem actually happens in the exam also, though you know the answer, but unfortunately you will go with the wrong answer. That's the main thing. You look into the basic factor here. What is that? Positive to negative, then again positive to negative, then again positive to negative. This is what the procedure we have to take here. Now you are getting the correct answers. Everyone is saying that's absolutely correct here. Now 6 is connected to 8 and 7 is connected to 10. I hope everyone got this part. Yes, very interesting. Earlier I was receiving some wrong answers, but now I was not saying that. I was just saying you give the answer. Now you are clear with this concept, I believe. Anyone having the doubt? Yes or no? Please reply. Anyone having the doubt? No, no, no. Very good, very good, very good. That's correct. Now I can say that my class is perfect. Okay, right. Okay, we can connect it, no doubt. So here D to P also we can connect, but no need. Now the battery is ready. Now the battery is ready. Fine. Everyone got this? Okay. Chalo yaar, let's go for the next question. Next question. Is the speed okay, everyone? Okay, fine. Let us go for the next question. Question number 3. Well, it's a very, someone is asking, well, can you explain it once again? Yeah. Okay, those who got it, for them. Okay, those who did not got last one, once again I am explaining. If you are getting confused, take the reference of this. Positive part is connected to the negative terminal of the next cell. Positive part is connected to the negative terminal of the next cell. First cell positive, next cell negative. First cell positive, next cell negative. Positive, negative. Same situation. Positive connected to negative, positive connected to negative, positive connected to negative, positive connected to negative. Those whoever has did not got, now I think you are okay with this. Now I think we are okay with this. Fine, that's great here. Now I will come back to the next question. Everyone started giving the answer for the next one. It's going to be very good, very good, very good, very good. I like it. Every student is giving the answer. Example of a primary cell are already you have gone through the last class. We have studied the primary cell is the example is a voltaic cell also is there. Daniel cell is also there, and dry cell is also there, and you can say it as a all of this. You can say it as a all of this. So now, so which one will be the perfect option for you? Perfect option matters here. So the perfect option is directly all of this is your perfect option. I think everyone got this part. No need of more detailed explanation because we have already did in our last session. And more than 100, I can say exactly 99%, yeah, 100% student gave the correct answer for this. Very good, keep it up. You can do more better. Very good, you are saying. I'm saying, and one more thing, I can believe that all the students are doing all 10 by 10 questions very perfectly, I believe. Let's go for the next part. Yes, option D is the correct answer for this. Now comes the next question. Now comes the next question. Why is tungsten used as a filament in bulbs? Let's go with this case. I will say you 3 important points about the bulbs. 3 important points about the bulb. So just roughly I'm drawing one bulb here. Roughly I'm just drawing one bulb here, which is actually just roughly I'm drawing, not a perfect one I am taking here. So this is our bulb, and inside this we will have one element inside the bulb. We called it as, this element is actually named as tungsten. Tungsten. Now the importance of this tungsten is, students started giving the answer. Very good here. So now the importance of tungsten is, the first important point, 2 important points you can say here. Tungsten is a filament, or we can say is an element which actually have very high melting point or high melting point. Very high melting point I can say, and this melting point will be approximately, some says 3200, some says, and some people says 3222, okay, degrees Celsius. This much temperature. Few people says nearly 3200, you can say nearly, some around, you can say, some people will say about this part. However, it is very high temperature for us. It is going to be very high temperature, approximately you can say 3200. You can remember this temperature, which is the very high. That means if you are giving that much amount of temperature, that means how much? 3222 degrees of Celsius if you give, then this filament, that is tungsten, start melting. Let me give you one better example for this. If I take water and I start it boiling, so its boiling point is nothing but what we can say, boil kahan par hua? It's a liquid, that's why we called it as boiling. So it will be only at 100 degrees Celsius. And in case of the liquid, if we are taking any solid or any element, when we start heating that part, it gets starting, instead of boiling, we say it as a melting. Any element or metal if you are saying, so we will take it as melting. And the tungsten is a filament or element which has a temperature of nearly or around 3200 degrees Celsius. Another important point about the tungsten is, it requires whatever the, now you just think about yourself in the, suppose you are observing, if you are heating up the water, what you are doing? Heating up the water. So what happens? The vapors will be coming out of the water because of the temperature, or because of the boiling, or because of the heating. Meanwhile, for a filament like tungsten, so if you provide a temperature around 1000 degrees Celsius also, it does not vaporize itself. So we can say at very high temperature it will vaporize, but not that much of vaporization is possible. Like any element, if you heat, what happens? The vapors will come out, but for a filament the vapors will not come out at any cost. I mean to say, if you are providing this much of temperature, at that time the vapors might come out, and that too, that vapors will be very low. That too, the vapors will be very low. In all those circumstances, we cannot reach to that much of temperature. So that's why this bulb filament is made up of tungsten. And then the answer for this case is nothing but it is not luminous, no. It is a soft metal, no. Next, it is a high, has high melting point is the one reason. It does not have the low melting point. So now we will see your messages. My goodness, so very huge messages I got so far, and all the students started giving the answer. Everyone is saying the answer for this is C. Now your C, I absolutely like that, but please remember the reason for this. Two important reason. It seems like very easy, but when it goes to the higher level, because of the much knowledge when you will be getting, you will forget very small points. I'll say you my experience, because I am actually a JEE teacher who teaches to JEE as well as for the NEET. I teaches for both JEE as well as NEET. Honestly speaking, I have experienced many students, though they know, because of the anxiety or pressure near to the exam, they will forget the easy points. So that's why whatever you are learning here, which reflects in your higher classes, try to memorize this forever. It seems like very easy if you are going in a flow, but if I turn back, after 6 months, if I turn back and ask the question, majority of the students might answer, but there are few students, and I am talking about those few students who face lot of difficulty. I hope everyone got this part. Let us go for the next question. Yes, please, next question. We will go for the next one, and I am able to see your messages here. Yes, you have studied in grade 8, very good, but once you reach to your 12th, at that time, if you are giving, you can say that part. Okay, so fine, let us go for the next question. Students started giving the answer. They are behind, they are away from my video, behind. I don't know about this part. Okay, do you have this PDFs with you? Do you have this PDFs with you already? Yes or no? మెసేజెస్ ఒకసారి చూడండి, వస్తలే, హ్యాంగ్ అవుతుంది. Just hold on. Do you have the PDF for this, students? Just hold on, don't answer now. Just I'm very far away of your old answers. Just hold on for a while, please. Oh, it's like 5,000 something change messages. Fine. Okay, still I cannot see your message, exact message, where exactly it is. Okay, fine, let's go for the next case. If you continuously message in that way, then I cannot see your messages here. Okay, no issue, let's go for the next case. So this is nothing but what everyone can answer for this here. So this is one small cell, then this is another small cell, this is another small cell, and you studied in the last class the combination of cells is basically defined as battery. So which battery is it? Electric battery. So I will go with option number D. I think your answer is also same. I cannot see your answers now because I'm far away. I tried my best to go further, but still not getting your exact answer, live answer. I'm able to see I'm having around 5,551 messages so far. And you want to break the record by sending the messages, I believe. Okay, let's go for the next question. Therefore, the next answer, next question is question number 6. Question number 6. Question number 6. I'll try here to see your answer. Students started giving the answer. Okay. Okay, some are saying C, some are saying D, some are saying all of this, all of this. Okay, fine. Your message is so fast that the one person who is messaging and automatically next person who is typing, automatically it's disappearing. Okay, that's great. Yeah, that's your energy. I like that energy. Yeah, very good, very good. Okay, fine, let's go with this case. An example of a conductor. First, what is the definition of conductor? Which allows the current to pass through them. Tap water consists of a water which is nothing but which allows the current to pass through them. Yes, this is absolutely correct. But salt solution also allows the current to pass through them. This is also correct. Next, metal wire. Metal wire allows the current to pass through them. Obviously, the metal conductor, basically mostly our metals are considered as conductor. So yes, basically from the metal wire the current flow through it. So therefore we can say metal wire is also a correct answer. But lastly, all of this, if it is there, then automatically this three will be eliminated. The perfect answer will be given for it. So as a result, I would like to remove all this one, and the answer for this case is going to be what? It's going to be all of this. All of this is a correct answer. You are absolutely correct in this answer. So far, whatever we did the theory in our last class, those questions has been repeated. I did not find any tough question here, any medium question also so far. Do you find any medium question? According to me, all these questions were easy. Do you find any easy medium question here? Did you find any medium question here? All were easy questions, right or wrong? Sir. Cannot see your messages. Hold on, I'm trying my best to see your messages, because interaction is important here. Interaction is important, and I'm very far away. Just hold on, please. Just hold on. We are coming up with your solution for it. Hold on. Okay. We're trying our best, but now the messages went to 8,000 plus. Okay, easy, 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 easy. Okay, 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 coming. Fine. Okay. Someone is having PDF, I say. Fine. Let us go for the next case here. Next question. Next question, answer is D for this. Now, which of the following is a bad conductor of electricity? Bad conductor of electricity. Bad conductor of electricity. Oh, bhai sahab. Arey, I like your energy, the way I'm seeing now. Literally, if you would have seen this message as how it is saying, as how the whatever the blinks will be going on, your answers are going on absolutely correct. Out of which I found 5 students so far who is giving wrong answer here. So some students are giving A as the answer. A as the answer. So that's wrong here. That's wrong here. That's wrong here. Let's come back to the point. Which of the following is a bad conductor of electricity? So bad conductor means nothing but which do not conduct the current, we can say. So acid is actually kind of salt water, you can say, kind of salt water, or acid is basically H2SO4 kind of. So this is a good conductor of electricity. It's a good conductor. Copper wire is also a good conductor of electricity. Copper wire is also a good conductor of electricity. Distilled water means nothing but we can say it as a pure water, and this pure water contains equal amount of electrons. So you can say equal amount of electrons, you can say, or you can say that a neutral part, you can say. Then as a result, and human, so as a result it does not conduct, so it is a bad conductor of electricity. While the starting two I will erase it. So these are the good conductors of electricity. And the finally human body Human body is a good conductor of electricity. Human body is a good conductor of electricity. Hence, option C is absolutely correct. Option C is absolutely correct. Now, anyone from the class, can you say me what is electric shock? Electric shock. Anyone from the class? What is electric shock? Because you all are answering, so I want to introduce that part. Electric shock means what? You define in your own language. Let us see. Anyone who can give the answer for this? No one. Okay. So basically, how does a person gets a shock? Basically, how does a person gets a shock? By transferring of electrons, yes or no? By transferring of electrons, yes or no? Okay, some are saying charge of electrons and neutrons, you can say. Okay, fine. I'll give you the definition for this. Firstly, how do a person gets a shock? Because the excess electrons will pass from the electric kit or current kit to the human body. That is what exactly the electric shock is. That is what I am able to, why I am taking this example, because I have seen this human body. That's why I am saying this part. So now I'll give you one definition of shock. Why it is called as shock? Why it is actually called as shock? This definition was given by my professor when I was doing my engineering. When I was doing my engineering, I also used to define the definition with you people, from my professor to me and from me to you people. So he asked one question to me, why we called it as shock only, why not other name? I'll see your messages. I think I can find some beautiful answers from your side. Okay, some students are giving the answer. Okay, when a person comes, just a minute, a direct contact with electrical source energy, allowing current to pass through electric body. Okay, that is your answer. My professor, when I was in engineering, he said only simple word to it, and that actually relate to the definition. You are absolutely correct, whatever the definition you are giving. But I also want to introduce you that word, what he said. He said only one thing: shaking human on current kit. Shaking human on current kit. Shaking human on current kit. This was the point that was given, said by my professor. When I practically thought that part, it's absolutely correct. Yes or no? Shaking human on current kit. So this is what the definition that my professor said to me, and yes, it's absolutely correct. He was of the age 70 plus. Okay, very good. Someone is saying that he told the answer. That's absolutely correct. Yeah. Wow, that's a great one. Okay, so shaking human on current kit. Yes, of course, the collision of positive and negative charges. That's absolutely correct. No doubt. I can say that is absolutely correct. But why this part? So this is what the shaking human on current kit. When human body came in my mind, I thought of expressing this part in front of you. Yes, I might not check your answer. You can imagine I have 10,052 messages to read, and I am able to see few messages. Sorry for that, yeah, I cannot answer for that. But yes, okay, very good. Some students are saying, you said, I'm saying you na. Okay, electricity. That's great. Whoever said, okay, right. So whoever said, absolutely correct. Very good for it. Okay, now let us go for the next case. Shall we proceed for the next question? Yeah. Shall we proceed for the next question? Now, see the question number 8. Question number 8. Question number 8. Which of the following is an example of secondary cell? Secondary cell. Students started giving the answer. That's absolutely correct. Absolutely correct. Very good. Very good. Very good. Okay. Okay. Fine. Some students are giving some wrong answers here. Some students are giving wrong answers also. Fine. आते ही जा रहे हैं यार तुम लोग के मैसेजेस. I'm able to see your answer. That's great. Sir, you కొంచెం కిందకి చూడండి sir. So కొంచెం కింద. Someone is saying A. Someone is saying A. No, yaar. Someone is saying A. Is it? Everybody is saying C. Let's see. Whoever is having the doubt, we can see. Voltaic cell. Acha, you say me voltaic cell is an example of what? Voltaic cell is an example of which cell? We will see this. यहाँ पर conclude हो जाएगा यार. Whoever is having the doubt. Voltaic cell is an example of which cell? Unable to catch your messages. Unable to catch your messages, and I can see your excitation. I'm very happy that you are ready. You are giving the answer. That's very, very good. Okay, voltaic cell, Daniel cell, and dry cells are the example of primary cell, and therefore I can see the final answer for this is nothing but secondary cell is Edson cell and lead accumulator. Did you remember this? But sorry, I cannot interact with you people because your messages are so much that I cannot see completely all your messages. Now I am able to see your answers. Primary. Okay, my operator is trying very hard to bring me your messages till me. It's trying very, very hard. Still we are coming up. Primary. Very good. Very good. Primary. That's great. Yeah, that's great. Okay, fine. Let's go for the next case. I found all the questions so far, whatever we did are actually easy questions. Okay, let's go for the next case. Let's go for question number. I am going for question number 9. Question number 9. C is the absolutely correct answer. Arey yaar, this question is looking very easy. Our body is. I have so much easy question. The answer is everybody is typing. That's great. Very good. Okay. Very good. Okay, so very good. So a good conductor of electricity, bad conductor of electricity, sometimes good, sometimes bad. Okay, and none of this. Fine. So I can say very simple answer. Our body is a human body which is a good conductor of electricity. Our body is a good conductor of electricity. Our body is not a bad conductor of electricity. Anyone from the class, can you give me the example of bad conductor of electricity? Anyone from the class? Bad conductor of electricity. Let's see who will answer for this. Bad conductor of electricity. I think I am up to the mark with your messages. No. So far I did not receive any message with my question. Bad conductor of electricity. Still I am receiving the answer for this as A. I'm very behind you here to see your answer. Still going on down, but I couldn't get your answer. Bad conductor of electricity. One of the example for the bad conductor of electricity. You people are very excited, very excited. इलेक्ट्रॉन भी इतना एक्साइट नहीं होगा उतना एक्साइटेड है यार तुम लोग. इलेक्ट्रॉन will also not get that much of excited. Okay, fine. Okay, but I cannot get your answer exactly. Still I'm receiving those answers only which you have given. A. It seems like a song that A like that. Fine, no problem. Let's go for the next question. Now I started receiving the answer. Plastic, wood, finally I got to receive your answers. That's great. Bad conductor of electricity. Okay, fine. Distilled water is also someone saying non-metals. I am able to listen. Very good. I actually received some good answers from your side. I am very interested to interact with you people very shortly, and when you come offline, we'll try to meet. No doubt, I will meet with all ninth class. Don't worry. Okay, I'll meet with all ninth class. Very, very interesting students. I'll come and meet with you people. Okay, fine. Let's come back to the point. Let us go for the next question. Wood, distilled water, plastic, wood, distilled water, rubber. Okay, fine, 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 fine. Okay, shall we go for the next question now? Might be you have sent that messages. I am receiving your messages 2 minutes late because I'm just comparing all those. Right now in my PC it's showing 11:13 and your messages are of 11:11. Okay, fine. Let's go for the next question, please. Next question. The answer is A for this. This one. Why do human beings get an electric shock? Don't take my definition and say here. Don't take my professor's definition. You say the answer directly for this and you can say direct answer for this. No doubt I am receiving your messages 1 minute late, but I am receiving your messages and that's absolutely correct. Let us see how many students are answering this. Why do human beings get an electric shock? Electric shock. Now I am receiving your answers. Everybody started giving. Okay. Yes. Wood. Fine. So everyone started giving the answer now. As I said, you 1 minute late because all those messages are coming up. So we are trying. Our operator is also trying to give the live. No issue. But anyhow, you are getting interacted with me, and your answer is absolutely correct. Absolutely correct. Why do human beings get an electric shock? So human beings are good conductor of electricity. Absolutely correct. Does the human being generates electricity? They will never generate the electricity. Human beings have life, so everyone will have life, but human beings, why reason we will come to know, because they are good conductors. Human beings are bad conductor of electricity. No, I can say one example for it here. Okay, life wala example agar aap dekhoge, if you see the life wala example, then you can say pigeons who sit on that electric wires will not get a shock. Will not get a shock. Yes, they will not get a shock, electric shock, because the whatever the pigeon's legs are there, from there the blood won't flow through it. One history says that. One mystery says that. Another one is nothing but they are made up of insulators, some people says, but the majorly the flow of blood is not there in the legs of the pigeon, and also they are also made up of insulator. That's why they do not get the electric shock. The pigeons won't get the electric shock, or the birds which sit on the electric wires, they won't get the electric shock. And here human beings are actually a good conductor of electricity. The reason behind that is our body consists of blood, and blood consists of electrons as well as protons, electrons most precisely. I can say it as a charges. So if I connect it to any current kit, what happens? The transfer of electrons from that current kit to me happens, and as a result the electrons will flow from the current kit to me, and as a result the definition shaking human on current kit, that is your electric shock, and that is why it is considered as a good conductor of electricity. So according to me and according to all you people, the correct answer is actually A. I hope everyone got this, all 10 questions which were actually easy. I'll try to connect with you people now. Last few things are left over for us. Fine. I'm trying to connect. I cannot see your messages. Sorry, yaar. Because I'm receiving your messages late here. So cannot connect you people. However, so today's class were only questions, very simple questions which you studied earlier also in our previous class, which in turns, acha, rate yourself out of those 10 questions, how many students were got all 10 of 10 questions correct? 10 of 10 questions correct. I might receive your messages quite late, but I will answer it, okay? Because right now I'm just getting a that's going on, and I can see on the right side it's showing 11:15, and but in my PC it's showing 11:18. Okay, 10, all the 10 questions correct. Before we discuss, all the 10 questions correct. Cannot connect you here. Someone is asking, in which branch do you teach? You will come to know. I'll say you on 21st of this month. Okay, I'll introduce you on that day about myself, on that day. Fine. Okay, so some question that which is completely seen. Which branch do you teach? Continuous question. I gave my words. I will say you on 21st of April which branch I teach, and I will introduce you myself on that day. Okay, some students started giving the answer 10 by 10. What about others? What about others? 10 by 10. Oh, bhai sahab, 9, 10, 10. Oh, 8. Okay, good. 10, 9, 10, 10, 10, 10, 10. Great, yaar. Great. Very good. Very good. That means you have the capability to learn all this, all the factors and remember it. That's very good thing of you. That's a very positive thing of you. Keep this positive thing with you always, always, always. Remember my word, keep this positive thing always with you, and you will crack whatever your destination you're targeting after your 12th. You will get it, whether you want to go for NEET, whether you want to go for JEE, you can. Fine. Okay, so 9, 10, 9, 10, 9, 10 you will be getting. Yes, please. Today's class we have completed. So I enjoyed learning with you people today. Hope you enjoyed the same. Thank you.